Assalamu alaikum. Dear students, this is Shamshad Ali, Foundation Engineering. Today we are going to learn about the choice selection of foundation. This is our week 2nd, lecture 2nd. Fifth semester, 3rd year of the program of BSc Civil Engineering Technology. You can access this lecture at portal.sud.edu.pk. So let's proceed. First, we will learn about the types of the shallow foundation, then deep foundation, and after that we will discuss that which type of foundation is to be selected for what type of the soil and for what type of the structure. So let's begin. Shallow foundation has 5 major types. The first one is strip footing. The second one is spread or isolated footing. The third one is combined footing, strap or cantilever footing. Strap or cantilever footing, mat or rough footing. We will distinguish between the combined footing and strap or cantilever footing. Okay. So first, strip footing. As shown in the figure, it is provided for a load-bearing wall and for a row of columns which are so closely spaced. If there is less space in the column, then you may provide the strip footing. This is the elevation, this is the ground surface level, this is the footing, strip footing. This is the elevation and this is the plan. The next one is spread or isolated footing or individual footing. It is clear from the name of this type of foundation, provided to support an individual column. It should be constructed for individual column, is shown in the figure. It is clear from the plan. This is basically this portion, and this is the erected column. Moving on. The third type of shallow foundation is combined footing. It is used when the two columns are so close to each other that their individual footings will overlap. As we have learned in your previous subject, soil mechanics, there is a chance to create a pressure ball. Here, the two columns are closely constructed. A combined footing supports two columns. It should be constructed for 2 columns. This is its elevation and this is its plan. Okay. Fourth one is strap or cantilever footing. A strap footing consists of 2 isolated footings connected with a structure, strap or a lever. Okay. If As we see that these are basically the two separated columns, this one and this one, but they are connected with a structure called strap or lever. Here in plan it is shown here, and in elevation it is shown here. Okay, the strap connects the two footings such that they behave as one unit. Now they are behave like they are behaving like one structure because they are connected with a lever or a strap. Okay, moving on, the fifth and the last type of the shallow foundation is made or rock foundation. A made or rough foundation is a large slab supporting a number of columns and walls under the entire structure. It is required when the allowable soil pressure is low. When there is low soil bearing capacity or low soil pressure, then you may select the made or rock foundation. As explained, there is a large slab which is shown here supporting a number of columns. Now these are the columns or the erected structure of columns, and there may be walls. Okay, so this is basically the made or rough foundation. It is also we can say that if the individual column area should exceed more than 50% of the entire area, then you may go to the made or rough foundation because it is economical. Okay, so moving on to the next topic, which is the types of deep foundation. In the next week, in the next lecture, we will learn more about the pile foundation and caissons. But first we are going to learn about these foundation types, because in the next slide you may know about the selection of the foundation. So for that, firstly we have to learn about the types of the shallow foundation and the deep foundation. So deep foundation has two types mainly. Further, they are also classified in different types: pile foundation and caissons. Okay. So the first one is pile foundation. Pile foundation are relatively long and slender members. As shown in this figure, these are the piles, the four structure which is called the piles. As we have previously learned that deep foundation is therefore provided because if there is no hard soil beneath the surface to resist the load of the superstructure. So As shown in this figure, this strata or this soil has lower density, so therefore it also having low bearing capacity. So therefore they pass this strata and go to this strata which has a medium density. So mean this soil has a little bit higher bearing capacity than this one. But its bearing capacity is not sufficient for the structure, so therefore they also pass this strata or this medium of the soil and go to the high density or high bearing capacity soil or the hard strata or the hard rocks. So therefore they reach to this soil. Okay, so pile foundation is provided for the high load of the structure, and it should be passed from the lower density soil and will be reached to the high density. These are the piles. These are the pile cap to connect these piles or to transfer or to equally transfer the load of the superstructure. And this is basically the load of the superstructure, which is building or bridge abutment or bridge piers, etc. Okay, moving on. Caissons. Caissons are hollow substructures designed to be constructed on or near the surface and then sunk as a single unit to their required level. As shown in the figure, this is a hollow structure. So this is basically in the picture, this is a hollow structure. And probably you see that this excavator is working under the caissons. So this is basically a hollow structure which is being constructed and then excavated at a required level. If you are going to construct it in water, then you may have to suck out the water to there, and then you are going to work inside this hollow structure. In next class we will explain it. Okay. Selection of type of foundation. Now this is the main topic of today's lecture. Which type of foundation will be selected? The following table tabulates the use of application of the several general foundation types. It is useful at this point to obtain a general overview of when and where a particular type of foundation is used. So, this is basically the table which I have copied from your textbook. Foundation types and their typical uses. This column shows the foundation types. This column shows the uses. And this column shows the applicable soil condition. At which type of soil condition will be applicable. For which type of soil condition this foundation is applicable. Shallow foundation. Generally its formula is D divided by V. If its depth divided by its breadth less than or equal to minimum, then it lies in the category of the shallow foundation. So first, spread footings or wall footings. Let's use individual column or wall. As we have learned that spread footing or wall footing will be used for individual column or for a single walls. Any condition where bearing capacity is adequate for applied load. This is the applicable soil condition. May use on a single stratum, firm layer over soft layer, or soft layer over firm. Check settlement from any source. You have to check the settlements first. Okay, so this is basically the spread footing or wall footing and shallow foundation. Now the next one is combined footing. 2 to 4 columns on footings and our space is limited. If space is limited or 2 or 4 columns, so it should be used. Same as for spread footing above. Okay, just like this type of applicable soil condition, it is also applicable for the combined footing. Okay, so the next one is made foundations. Where you can use the made foundation? Several rows of parallel columns, heavy column loads used to reduce differential settlement. If you want to reduce differential settlement, you may use the made foundation. Or if there are several rows of parallel columns, or there are heavy loads. Okay, which type of soil is applicable? Soil bearing capacity is generally less than for spread footings. Soil bearing capacity is generally less than for spread footing, and over half the plan area will be covered by spread footing, as we learned in the previous slides, meaning the 50% of the whole area. If the spread footing area is greater than 50% of the whole area, then you may use the made foundation. Check settlement from any source. Here you can also check the settlement from any source. Moving on, now the deep foundation. Generally, its length divided by its breadth. If it is greater than or equal than 4 and above, then you may, and then this type of foundation lies in the category of the deep foundation. If your foundation length or its breadth is greater than or equal to the 4 or its on and above. Floating pile, which is a type of pile and group of 2 and above supporting a cap that interfaces with columns. This is the use where you can use the floating type. Okay, surface and near surface soils have low bearing capacity, and competent soil is at great depth. Sufficient skin resistance can be developed by soil to pile parameter to carry anticipated loads. Now, bearing. Same is for floating. Okay, this category, this file is also used for this type. Applicable soil condition. Surface and near surface soil is not relied on for skin resistance. Competent soil for point load is at a practical depth, which ranges from 8 to 20 meters. Drill piers or caissons. Same as for piles, used for large column loads. If there are large column loads, then you may use the drill piers or caissons. Same as for piles, maybe floating or point pier or combination. Depends on depth to competent bearing strategies. So, moving on, retaining structures. earth retaining structure, retaining walls, gable wall, mechanically stabilized earth wall. These are the types of the retaining wall. Retaining walls are bridge abutments. Where should we use? Permanent material retention. If you want to permanently, this is basically retaining wall, if you want to permanently retain the soil behind this structure, then you may use the retaining wall or bridge abutments. Any type of soil but a specified zone. We will learn these types in the next chapters. And backfill is usually a controlled fill. Backfill material. Material which is used behind the retaining wall is called the backfill material. So it should be a controlled fill. Sheeting structures. Sheet pile, wood sheeting structure. Pile has many other types, which is sheet pile, wood sheet pile. So we will learn in the next lecture about the types of the piles, types of the deep foundation in detail. Temporary or permanent for excavation. Sheet pile or the wood sheet pile are used where you can temporarily excavate something. Excavate the soil. Marine cofferdams for river work. Retain any soil or water. These structures can retain the water as well as the soil. Backfill for waterfront and cofferdam systems is usually granular for greater retainage. Okay, so moving on, selection of type of foundation. Where the groundwater table is present, groundwater table, the water beneath the ground surface called the groundwater. You are definitely familiar with this terminology. It is common to lower it below the construction zone. You have to lower it below the construction zone, either permanently or for the duration of the construction work. If the groundwater table must be lowered either temporarily or permanently, it is usually necessary to get approval from the Environmental Protection Agency. You have to follow the rules and regulation of the Environmental Protection Agency first, before lowering the water table. Either it should be permanently or either it should be temporary. Also, there is a potential problem of causing ground subsidence in the area surrounding the construction site if there is significant lowering of the groundwater table. For this reason, it is a common practice to construct water barriers around the site perimeters and only pump out the interior. To protect yourself from the environmental protection agencies, okay, and also from the potential problems of causing ground subsidence, there is a solution to construct water barriers, meaning the caissons or the cofferdams, around the site perimeter where you are going to construct something on your construction site, and then only pump out the interior. Okay. Now, the depth of foundation. How much depth is required for your foundation? So depth must be adequate to avoid lateral squeezing of material from beneath the foundation or footing, sand, mats. There is adequate depth to avoid lateral squeezing. If you construct a hole in your ground and its depth is large enough to cause the lateral forces occurring from the adjacent soil. So depth should be and depth must be adequate to avoid lateral squeezing of material, lateral squeezing of the soil, or lateral squeezing of the water in case of the cofferdam and caissons. Okay. Similarly, excavation for the foundation must take into account that this can happen to existing building footings on adjacent sites and require that suitable precautions be taken. Okay. The number of settlement cracks that are found by owners of existing building and excavation for adjacent structure begin is truly massive. Depth of foundation must be below the zone of seasonal volume changes caused by freezing, thawing, and plant growth. These are the precautions that should be taken for excavating a foundation. Most local building codes will contain minimum depth requirements. There is a minimum depth requirement in the local building codes. And next class we will explain and we will learn about the deep foundation in detail, which are piles, caisson, piers, well foundation, types of piles, pile capacity in the pile group. So, dear student, this is it for today. Hope you will learn something about the foundation, its types of foundation, and depth of foundation. If you have any question, kindly let me know in your student portal. So thank you.